Take two. I just made a video explaining the answers to the review problems from Friday's folder, and it took me 23 minutes, and I didn't even get to the fourth page. So I'm going to do all four pages and try and go a little faster this time. Problem number one gave you this information. You reflect AB across, and it ends up somewhere like this, B prime, A prime, which also has a length of 12, because when you reflect, the lengths stay the same. Now, in the problem, it tells you that from B all the way to A prime has a length of 30. So we have 12, and then we have 30. We know the whole thing from A to A prime is 42, 12 plus 30. And L is always right in the middle. Your line of reflection is always right in the middle. So each one of these sides must be 21. And if that much of it is 12, the rest of it is 9. So your answer was 9 on that one. My recommendation on a problem like this is draw the picture, draw what it looks like after you reflect it, fill in the information they give you, the 30 and the 12, and then you can fill in the blanks from there just by adding and subtracting. All right, the next one, you had to rotate a triangle around one of the points on the triangle, specifically point C, which was right there. You had to rotate it 90 degrees. So, and they ask you about point B's. If that's the center of your clock that you're rotating around, you're pointing at 3 o'clock. 90 degrees clockwise, you'd be pointing at 6 o'clock. So B prime is going to go down here. That means B to C to B prime had a 90-degree angle. The hands on your clock form a 90-degree angle if you rotate them 90 degrees. It's kind of, they go together. All right, third one, reflect across. All right, this is a tough one, and this took me a long time to explain the first time, but here's the quick and easy way to do it. Plot your point that they give you, which was 4, 2. Plot the intersection point, which they give you, which was 1, negative 2. And then see how far it is between those 2 points. So take the 2 points and see how far apart they are, which was 3 spaces over and 4 spaces down. You had to go over 3 and down 4 to get from one point to the next. And which one of those points is on the line of reflection? I. They tell you I is the intersection of the line of reflection and the line AA prime. So it's on the intersection, it's on the line of reflection. That means this point A prime up here must have started on the other side of this point. Not up here, over here on the other side of I. So you go to the other side of I this same distance, 3 and 4. And over 3 from 1 is negative 2, and down 4 from negative 2 is negative 6. So that was your answer on that one, negative 2, negative 6. Find that and go that same length past your intersection point. Okay, number 4. You had to do true or false for all 4 of these. Could you reflect across the x-axis? We're going from here to here. How do you get from here to here? There's more than one way to do it, so you got to check each one of them, see if they work. First one says reflect across the x-axis. So that would flip up here and then translate. So you'd have to slide. Could this slide over and match right on there? No, it could not. You'd have to rotate it somehow. Can't just slide that shape to here and match it. They don't have the same orientation. So false for A. B, translate straight up. So instead of flipping up, now we're just sliding straight up. Translate means to slide. So we're up here somewhere. And then rotate 180 degrees. This point would go to there because those are both C's. This point would go to here. Those are both B's. Those lines cross. So yes, the rotate of 180 would work. So that was a yes, true. All right, reflect across the y-axis. So now we're going to flip this way. So our triangle is going to look like this. So it almost matched. We're just kind of upside down. We would have to flip it again. And that's what the next thing says. Flip it over the line y equals negative 2.5, which is in between 2 and 3, right here. And yes, if you flip it over that line, that point stays where it's at because it's on the line. This point goes to the other side right here. This point goes to the other side down here. And yes, it matches up with that triangle. So yes, it worked. And then the last one, rotate clockwise 90 degrees. Clockwise would be that way. So you would end up here. And then reflect across y equals x. That's A. That would have to go to here. This is B, that would have to go to there. Those lines cross, so it cannot be a reflection. If it's a reflection, the lines connecting your corresponding points are parallel. So the last one was false. So it was false, true, true, false. Number 5. It says, what theorem could you use if 1 and 2 are a linear pair to show that 1 plus 2 is equal to 180? Well, linear pair means that they are a total of 180. The sum is 180. If you have two lines that cross and 1 and 2 are right next to each other, that's a linear pair. They add up to 180. So it's a linear pair postulate. So that one might have been confusing because you might overthink it, but it's that easy. They gave the answer basically right in the problem. If they're a linear pair, you use linear pair postulate or linear pair theorem, whatever they might call it. All right. Triangle ABC. They don't draw the triangle, they just give you the coordinates, so you should draw them. You have -4, -3, and -4, 6, and 6, 2, so somewhere like that. To find the area of a triangle, it's base times height. So one of these three sides has to be the base. Don't just automatically pick the bottom. Pick the one that's either straight across or straight up and down. The bottom here is not straight across, it's diagonal. The left-hand side is straight up and down. That's your base. So how tall was that? You were all the way down at -3 and you went up to 6, so that had a length of 9. From this straight across to the tip, how far is that? Well, you're already over at -4 and you had to go all the way to 6, so that had a length of 10. 9 times 10 divided by 2. Base times height divided by 2. 90 divided by 2. 45. 45 was the answer to number 6. All right, since the lines are parallel, then these angles are equal because they're corresponding angles. Corresponding angles are equal, just like alternate interior, just like alternate exterior, if your lines are parallel. So since they're equal, you set those two expressions equal to each other. That was the top angle, this was the bottom angle, and then you just solve for x. You combine your x's. I subtract the smaller ones so they stay positive. And you have 12 is equal to 5x minus 13. Then you add 13 to get 25. And then you divide by 5 to get 5. So x is equal to 5 there. All right, number 8. Choose the line that is parallel to this one. Choose a line that is parallel to 5x plus 2. Well, if it's going to be parallel to that line, it has to have the exact same slope, which is 5. So our new line must have a slope of 5, and only one of these choices has a slope of 5. Which is D. So it had to be D. You didn't even have to solve for B in that one, which if you did, you found another mistake of mine because B was actually -17 on that one and I wrote -21, so that was probably confusing to some of you, but if you notice that the slope had to be the same as this because they're parallel, it had to be 5. That's the only one that's 5. It had to be D. So look at your slopes first. Make sure they're the same. All right, number 9. You know what, I should show you how to find the slope because you're going to have to know how to do that. So let me go back to that one real quick, take up a little bit of time here. Our new M was 5 because it's the same as the original line, which was 5. To find the new B, you have to substitute in for Y, M, and X. If you substitute in numbers for those three, you can solve for B. You can always solve for a letter if everything else is a number. So what do we use for those numbers? We use the point that they give us. They give us 2, -7. That's an x and y coordinate of a point. So that's x, that's y, that's m. So y is -7, m is 5, x is 2. 5 times 2 is 10. Subtract 10 to the other side, and you get -17. So like I said, that was wrong. -21 was wrong, -17 was correct. But that's how you find B. You need to know how to do that. So that's how you do that. You substitute in for Y, M, and X, which they give you X and Y, and they basically give you M. It's right here in this equation. Okay, moving on to number 9. Area and perimeter of a trapezoid. Area is 1/2 the height times something in the parentheses. So what is the height here? The height is from the top straight, from the bottom straight up to the top, from 2 up to 6. So the height is 4. Half of 4 is 2. So it's 2 times B1 plus B2, which stands for the length of the bottom and the length of the top. So what is the length of the bottom and the top? And then you add those together. The length of the bottom is from -3 over to 2. That is a length of 5. The length of the top is from -5 over to 4. That is a length of 9. 9 plus 5 is 14. 2 times 14 is 28. So your area was 28 on this one. All right, how about the perimeter? Well, you need to add up all 4 sides. We already have 2 of them. We just need the left and the right-hand side, which are at a diagonal, so you have to use Pythagorean theorem. How far over and how far up to get from one point to the next? From 2 over to 4, that's a length of 2, and we already knew the height was 4, from 2 up to 6. Same with here, it was over 2, from -3 to -5, and up 4. So they're the same. They're both 4 squared plus 2 squared. They're both 16 plus 4, which is 20. So they're both the square root of 20. So we've got 9 plus 15 plus square root of 20 plus square root of 20. And you get 14 plus 2 square root of 20. And you can break down square root of 20, but I showed you how to do that, but that was kind of like enrichment. You really don't need to know how to do that at this point. So I'm not going to dive into breaking that down. Technically, that would break down into 2 times the square root of 5. So if you ended up with 14 plus 4 square root of 5, that's like extra credit. That's perfecto. But if you did not get this, that is just as good. This is the right answer. Number 10. 2 answers to this one. First of all, hopefully you erase the y equals. I did give you the directions on that in the do section there. All right. To know what slope is going to be parallel to this, you have to put this in slope-intercept form. So you have to solve for y by subtracting 4 to the other side and then dividing by -6. So that's -3. And a negative divided by a negative is a positive. And 6 reduces to 2/3. So that's our slope, 2/3. So the parallel slope is 2/3. A perpendicular slope is the reciprocal and the opposite sign. Reciprocal is 3/2. Opposite of positive is negative. So those were the 2 answers I was looking for. Parallel was 2/3. Perpendicular, -3/2. All right, number 11. Moving right along here. Making good time, people. You're welcome. All right, this was like 4 problems in one. They wanted to know which one of these was not parallel or perpendicular to that graph. So what is the slope of that graph? We need to know so we can compare it to this. The slope of this graph was, first of all, a negative number because the graph is going down to the right. And it's down 1, 2, 3, 4 as you rise, and 1, 2, 3, 4, 5, 6 as you run. Oops, that was supposed to be a negative sign. 4 over 6, which reduces to -2/3. So anything that has -2/3 or +3/2 is not the answer we're looking for, because that would be parallel, this would be perpendicular, and we want something that's neither one of those. So we want a slope that's anything but those 2 numbers. So you got to figure out the slopes of all these by solving for y. So subtract 2x and divide by 3, and you get -2/3. Subtract 3x to get -3x, divide by -2, negative divided by negative is a positive, so that was a +3/2. You don't even need the x. So the slope there was 3/2. A was -2/3. Here you subtract 12x, divide by -8, which gives you a positive, and then you reduce that, and you get 3/2. Okay, so that was the same as this one. So far, we don't want any of these, because that's parallel. And these are both perpendicular, so hopefully this is something different here, or I messed up again. So you subtract 4x to the other side, you divide by -6, which gives you a positive, because a negative divided by a negative is a positive, and that reduces to 2/3. 2/3 is neither one of those numbers. That's the one we want. So D was the right answer. It was neither parallel nor perpendicular. All right, the last one. J and K are parallel, which I did not label J and K, but they're the lines that look parallel. This one and this one, this one and this one. So since they're parallel, alternate exterior angles are equal. So 78 was equal to x, and 82 was equal to y. They're both alternate exterior. The only way this one could be tricky is if you squeeze these 2 pictures together. So you had 4 lines in one picture, 78 and x. Don't say x is equal to 82 because they're not. They're not alternate interior, and these are not alternate exterior. They're on the same sides of the transversal. So just be careful on that. All right, last page. This was your constructions review. Which one of these was which? So you had 6 pictures. You had to match up to 6 titles, basically. So which one is angle bisector? Which one is splitting an angle in half? This one. So that was A. Okay, copy a segment. Which one is drawing a little segment that's the exact same size as the first one? Right here. So that was B. Parallel lines. That was probably a tricky one. None of these lines look parallel. So what the heck is parallel lines? Well, it's this one. Because look, whenever you see 2 little arcs that cross, like you do right here, you're going to end up drawing a line right through that from another point. And there's the point. So if you draw the line right through there, now you've got your parallel lines. All right. And same with, so that 13, that was C. So you had the first one, angle bisector. This was A. And that's another thing. Here's 2 lines that, 2 arcs that cross. You're going to draw a line right through there to where you're trying to split your angle. So that you're splitting your angle in half. That's your angle bisector. Copy a segment. That was B. All right. Perpendicular bisector and equilateral triangle, remember, are pretty similar. You're drawing a circle around the endpoints of your segment, just like you are here. But this circle happens to go, wait a second, this segment's right here. This circle right here was just more than halfway to that point. If I would have drawn this circle right through that point, now it turns into that. This circle right here went right through that point. And the circle around here went right through the other end point. So that means you have an equilateral triangle. So this was equilateral triangle. This was just regular old perpendicular bisector. So then this last one was copy an angle, because look, you have the 2 arcs that cross. So if you draw a line through those, now you have the same angle as what you had. You're copying an angle. You guys should do pretty good on these. It's pretty clear in the picture, except for maybe parallel lines, what they're drawing. What they're drawing. Okay, now on the last one, you had to say, are these 2 equations perpendicular to each other? And I was nice. I put them in slope-intercept form. So the slope of the first one was 3/5. The slope of the second one was -5/3. Are those perpendicular? Yes, because if you flip 5/3 or 3/5, you get 5/3. They're reciprocals of each other. One's positive, one is negative. That means perpendicular. So it says if so, which means if they are perpendicular, which they are, what is the product? Product is an answer to a multiplication problem. So you have to multiply those. 3 times 5 is 15. 5 times 3 is 15. Positive times a negative is a negative. So negative 15 over 15. Whenever you have the same number on the top and the bottom, it reduces to 1. So that was -1. Okay, next one. This was not in slope-intercept form. So you had to subtract 3x and divide by -7. So subtract your 3x to the other side, divide by -7. That gives you a positive 3/7, because a negative divided by a negative is a positive. Here you had to subtract 14x, you get -14x, and divide by a positive 6. So that's going to stay negative, because only a negative divided by a positive is negative. And this reduces to 7/3. Those are both even. You can split them in half. So are those reciprocals of each other? Yes. Is one positive and one negative? Yes. So they are perpendicular. That means you needed to give me the product again. So you multiply those together. 7 times 3 is 21. 3 times 7 is 21. Positive times a negative is a negative. And it reduces to -1, just like the one above. So that is a pattern there. If your slopes are perpendicular, when you multiply them together, it's going to equal -1, because they're reciprocals of each other. One's positive, one negative. It doesn't matter really what the numbers are. When you make them reciprocals, you're going to get 1 when you multiply. And since one's positive and one's negative, you'll get -1.